welcome back. Now, in this video, what I wanted to explain to you is the second of the two methods of solving a 2x2 system of equations. Now, in the last video, I went over a substitution, and that, like the other example, x plus 5 is equal to 10, and then you solve for x by subtracting on both sides, and you find out that x is equal to 5, right? That's horrible 5. So anyway, what we pretty much did was find out x. And in the last video, what we ended up doing is substituting, say, if I were to do substitution for this equation on the bottom, I would include, if I were to find the value of x, I would input it into the equation to where we would have sort of a y plus something, or just a y with a coefficient next to it, inputted into x, so that we would have nothing but y variables, and then solve for the y variable, and then solve for x afterward, so that we find out the two values of x and y. And basically what we were doing is eliminating, right? So you will find out that the second method is like it in some ways, but different in others. And this method is known as elimination. It's more of a cutthroat and an aggressive approach to an equation. You will find out that it depends on the situation that you're given on whether or not you want to use elimination or substitution. And this one is one reason why. And I actually want to get rid of that bracket, because what you want to do is you want to sort of think about this equation as combining them, right? You want to combine the x values, and you want to combine the y values, and you want to combine the numbers that they equal to. Now, before we do that, though, we want to make it easy on ourselves, so that we only have one variable, sort of like the last method of substitution. So what we do is, let's sort of imagine a plus sign right here. What we do is we cancel out not only the coefficient, but we cancel out the variable. And how do we do that? Well, we can see that on this side we have 4x and 4x. We have 4x in both equations, right? So what we end up doing is, basically what we do to one term, we can do for the entire equation. We want to be able to cancel this out, and how we do that is by making this term negative. And like I said, what we do to one term, we do to the entire equation. We multiply this entire equation, we put it in parentheses for inclusion, we put sort of a negative sign. I could put a negative 1, but I'm going to put a negative sign there just to sort of save space. So what we do, we can write out this whole situation out right here. We have 4x, this is the top equation, 4x minus 9y equals to 26. Now, since we multiplied this bottom equation by negative, making this whole whatever is positive now becomes negative, and whatever is negative, a negative times a negative becomes positive, whatever is negative becomes a positive. So now we have negative 4x plus 5y is equal to negative 2. So it's sort of like viewing it as opposite. Whatever used to be one way is now the polar opposite. So now we can view this as sort of just adding. You add this column. If it's kind of confusing, you can sort of view it as column. This is column 1, this is column 2, and this is column 3, right? So now that we view it like this, we can literally eliminate these terms out of the entire two systems of equations. So basically, this becomes 0. So now we have negative 9y plus 5y, which is negative 4y, right? So now we have 26 minus 2, and that amounts to 24. So to completely isolate y, what we do is we divide by negative 4. We do it on both sides, and we result in a positive divided by a negative is a negative. So we know that 24 divided by 4 is 6, and since it's a negative, it'll be negative 6. We know now that y is equal to negative 6. So what we've done is we have eliminated the x values, and so that we have only y. We only have y terms, so that it's easier to solve for one variable. So we now know that y is equal to negative 6. With that information now, we can solve for x. We can choose either one of these equations, but for simplicity, I want to choose the one that equals to the lesser value, because I want to save time by not having to deal with this big number 26. So we have 4x minus 5y is equal to 2. Now what I do is I substitute negative 6 in for y. So we have 4x minus 5 times negative 6 is equal to 2. Now what we do is, because since it's in an equation, this is perceived as just a minus sign, right? But since it's next to this 5 and it's being multiplied by a negative 6, we can just view this 5 as a negative 5. Just imagine this sort of as an entire term, right? Let me cancel that out. So negative 5 times negative 6 is a positive number, and we know that 5 times 6 is 30. So 4x plus, since it's a positive number, since negative 5 times negative 6 is 30, 4x plus 30 is equal to 2. Wow, looks like I'm already dealing with a big number regardless. So what we do now is, since we want to isolate x, we can subtract 30 from both sides. Now, whenever you're in a situation like this, well, oh no, I don't really want to visualize a number line in my head, and I don't really feel like counting my fingers. I don't really feel like counting my fingers and toes. Basically, what you can do is you can sort of switch. You can sort of move this negative sign sort of to like the 2, and you could have the 30 on top. So it would be like 30 minus 2 is equal to 28. But since it's in the opposite case, since the bigger number is now a negative, you would put the negative number next to that result. So we know that 30 minus 2 is equal to 28, and you put that negative next to the 28. So we have 2 minus 30 is equal to negative 28. So now we have 4x equals to negative 28, right? To isolate x fully, we divide 4 on both sides. We know that 28 divided by 4 is equal to 7, and since 28 is a negative number divided by a positive number, it's still negative. So now we have negative 7. And our solution set is negative 7, comma, negative 6. And we are done.